Okay, I'm going to start. I'm going to do some word problems, work until around 7:30, more or less, like that. And then at that time, Lisa and I are going to split the classroom up into two areas where we think we can maybe give you some help before tomorrow's test exam. Okay, I'll talk more about how we're going to split the class when we get there. Okay, but right now I want to teach. I will have to remind you, I have to erase this, but the exam is tomorrow. If you don't know that, you're in big trouble. Do it on your own paper again, spread it out, use as much room as you need. Okay, I don't want you to squeeze things in. You do need a scientific calculator, no notes, but you can do a brain dump. We talked about that last night. Also, while I'm kind of talking, if you get that worksheet that I handed you last Thursday, the word problem one, I'm going to try and get through as many of those in the next hour as I possibly can. So here we go. Okay. On the worksheet, there is something called, there's a type of word problem called projectile motion. And what it's based on, it's if you shoot a rocket in the air, okay? If you shoot a rocket in the air, it goes up and comes back down. It makes what we call a parabolic or a parabola curve, okay? And this is really easy to study. And we use it, we're using it now. You're going to use it quite a bit in calculus because a lot of calculus techniques are really easy to show and explain on a parabola, this kind of thing, or to talk about the motion of a rocket or a bullet or a rock or something just shot into the air and it comes back down. Now, the formula that you kind of need to know, so don't panic yet, it's h of t equals -1/2 gt squared plus v sub 0 t plus h sub 0. Now I want to talk about that. Okay. Do you need to know this? Yes and no. I will always give you the front part. I'll never give this 1/2 gt squared crud. I'll give you an example of that. But you have to know what the v sub 0 and the h sub 0 mean. You have to know that and be able to interpret that. So v sub 0 is also known as v naught, N-A-U-G-H-T, and that's left over from the British, when the British, Isaac Newton and all those guys, okay? In math, we call it v sub 0. In science, they call it v naught. Naught and 0 mean the same thing to us, okay? And it's the initial velocity of an object. Think of velocity as speed. It's not actually, but think of that. The implication is when time equals 0. So when we talk about initial velocity, that's at the beginning of whatever this problem is. So when you shoot a gun, okay, what's the initial velocity of the bullet? So the instant you pull the trigger, now the bullet starts to go up. That's called its initial velocity when time is 0 at the very beginning of this experiment or of this problem. Okay, h sub 0 is also known as h naught, N-A-U-G-H-T. And I'm going to say it's drummed into me. I don't call that v sub 0. I call it v naught. Okay. If over the next week or so we're doing these problems and I say v naught or h naught and you don't understand, please ask over and over and over again. I don't want you to get lost. Okay. But h sub 0 or h naught is called the initial, okay, height okay, and implied when time equals 0, okay? Now, one of the things you do need to know is when you are on the ground, h or h naught is 0. That's an implication. So when we say, hey, you're standing on the ground shooting the bullet in the air, don't worry about how tall I am. We don't care about that. Okay. I'm not going to try and trick you that way. Okay. So when you launch a rocket from the ground, its initial height is implied to be 0. But we're gonna have times when, okay, well, maybe we launch a rocket from the top of a 2-story building, goes like that, or maybe we launch a rocket, like an ICBM missile from below ground. Maybe it's a couple hundred feet below ground. The little doors open up and the rocket shoots up and kills everybody. Okay, so the height h sub 0, the initial height, when it's on the ground, it will be worth 0, but it could be on the top of a building or on the top of a mountain, or it could be underground. And I'm going to try and give you examples that show all this. Okay. What do you need to know? These are the basics. Okay. This right here, okay, I will always give you. You do not have to worry about it. This is the physics formula. This is what Newton kind of figured out, and other people too, but that's the force of gravity. The instant we start throwing something up in the air, gravity starts pulling it down. So this first number here, okay, is the effect of gravity on whatever your object is. The effect of gravity changes depending on what planet you're on. On Earth, the effect of gravity, is different than on the moon, different than on Mars, different than on Jupiter. Okay, so this number changes depending on what planet you're on. Okay, also, this number changes depending on what units you're using. If you're using meters per second or feet per second or something like that, then we stick a different number in here. Now, that's the physics part of it. You will never have to know that. Okay, that part of the problem I will always give you. But you'll have to be able to read the problem and select out the V naught and the H naught. Okay, now I need to erase the board, and I'm going to do the first problem on that worksheet handout. So is there any question about the formula? I'm going to put it up again in a second, but what does V naught stand for? What does H naught stand for? And the fact that I will always give you this circled part. You don't have to worry about it. I'm just kind of telling you about it right now. So any questions about anything I've said or done so far? Okay, so reading the first question, the first word problem, it says a projectile is fired straight upward from the ground and its height in feet is given by, and I give you this formula. So first problem, I give you h of t is negative 16 t squared, what did it say? Plus 96t. And it's assumed to be plus 0 because it said from the ground. Okay. Now you don't need to put that in, but you should know that it's implied. That's H naught. That's your on the ground. Okay. So I've given you the entire formula here. You don't have to think too much. Okay. It says there's a there's I'm going to add a new problem to this. I'm going to add question double A. How high is, what is this, a rocket? A projectile. Is projectile after 5 seconds? Yeah, because this is time a second. So this was not a question on the worksheet. I added it. How high is the projectile after 5 seconds? Well, notice something. 5 seconds is time. This is a time thing. And how high means the height is unknown. How high is it? Okay, I don't know. How high did this thing go? So what this is saying mathematically is this is asking us to find h of 5. The height after 5 seconds. We're just plugging in 5 for time. And so we run here -16 times 5 squared, because time is 5, plus 96 times 5. Okay, and if you want to use the plus 0, you can. This is just a matter of popping it all into your calculator. This is the easy part. Okay, how high is a projectile after 5 seconds? So, what do I have? Let's see if I can get it. Turn it on. Okay. I get 80. Is that right? Let me do it again, because I tried a trick and I want to make sure I didn't screw it up.
Yeah, it is 80.
80? That's okay.
Yes.
I tried a trick and I wanted to make sure I get mad at myself when I make dumb mistakes up here. I know math is hard, and when I make a dumb mistake, I make it harder for you guys. So I get really angry. So reading the directions, it said height was in feet. So how high is this thing? It's 80 feet after 5 seconds, according to this formula. That's all it says. Okay, so that was the easy one. That was not on the worksheet, but I wanted to do it first just to show, to get you to see how to read this. How high means the height is unknown, but the time is 5. So we can plug 5 into t, which is time. Now, reading the second question. When does the object hit the ground? This is actually question A. When does object hit ground? Question mark. When does the object hit the ground? Now, again, this comes down to your reading of English. First off, when means the time is unknown. Okay, is the orange showing up there, or do you want me to go to another color?
If we can you use in black, please?
Well, I wanted something that stands out other than black. So it's a little bit different. I understand, though. Okay, what did I do with all my colors? It's not good. Okay, so when I'll try it in black, see what happens. It means time is unknown. Hit the ground, okay, right here means h, the overall height, not the initial height, but the overall height is 0. Okay, so again, a lot of the confusion comes in understanding the English. When means solve for time. If they don't know what the time is, then we're going to have to solve for it. Solve for time. Does it hit the ground? This is h equals 0, not h naught. So the problem becomes 0 because that's height at a certain time equals negative 16 t squared plus 96 t. See, this was the height. And at some time, the height is going to be worth 0. What this is saying is our object is going to go up, come down, hit the ground. And we want to know, when does it hit the ground? What is the time it takes to hit the ground? So again, please understand, this was height after an unknown amount of time. Height is going to be 0 eventually, but it's held to this formula. Well, now check that problem out. That's a quadratic equation. Okay, it's a second degree equation, and we have about a gazillion ways to solve it. You can use factoring, completing the square root property, the quad formula. You can use anything you want as long as you get it right and as long as it's mathematically correct. I'm going to factor this. So to factor this, first off, I'm going to move everything over here because I like my t squared to be a positive. So if I add 16t squared to both sides, I get 16t squared minus 96t equals 0. And that's just the Foster. You don't have to do that. So here I am. That was stupid of me. 16t squared plus 96t equals 0. Same equation as I had down here. All right, solve it. I'm going to factor it. Okay. I happen to know that 16 goes into 96. But it doesn't matter. What if you didn't know that? Okay. Let's see what happens. At the very least, we can take out a t. That leaves me 16t plus 96 equals 0. Remember, solve by factoring, make it equal 0, then start to factor. And now separate it, either t equals 0 or 16t plus 96 equals 0. Yeah, I have to.
Hey, Professor, shouldn't it be up there 16t squared minus 96t?
Yes, should. Good thing you guys are smart and you're overcoming your idiot instructor. Thank you. Minus, minus, minus. Sorry. Make that change, guys. Has anybody invested in a stamp that says Foster is stupid yet? Reminds me of a quick story. I know we want to get out of here. One time I was in high school. Remember I told you that in high school I can intimidate the kids. I used to always say, no work, no credit. No work, no credit. And I got a stamp made. Went to Kinko's or somebody and got a stamp. You know, one of those things you stamp with red ink, and then you could stamp the paper. And the stamp said, no work, no credit. So one time during a test, the students in my second class are taking this test, but I'm grading the papers from the first class. So I'm sitting there, I'm grading the papers, and all of a sudden I go, boom, grading the papers, boom, grading the papers, boom. And finally, the students in the class going, what are you doing? I'm saying, I held up a paper with this big red mark. It goes, no work, no credit. These people are getting screwed. Okay. Man, you should have seen all the work I was getting from all the kids after that. It was great. It was wonderful. I had to laugh, but that's just me. I guess that's a teacher thing. All right. So anyway, here we go. This is solved. This one, 16t equals 96. Add 96 to both sides. Divide both sides by 16. Whoops. Is it 6? Is that right? You guys that are smarter than me? I think it is.
Yeah,
Yes.
that's 6.
6. Okay, so what's it mean? I get 2 answers. I get 2 answers. Think about this. Okay, it said I'm standing on the ground. I'm going to knock this thing in the air. It's going to come back down. So what's this t equals 0 mean? That means at the start, it was on the ground, which I already knew. So you remember, we're talking about when is the height worth 0? Well, when time is 0, because it said we start on the ground. And then it goes up and comes back down. And this is where time is 6. So after 6 seconds, this object or whatever it is would have gone up and come back down, hit the ground. Okay, so that's what your math is trying to tell you. It's still going to give you 2 answers. Okay, it's going to give you those 2 answers, but you have to interpret them. I want the one when it hits the ground, not when it starts. Okay, next one says, when is the height 48 feet? Okay, now I kind of need to erase this work here. So I'll wait for 2 things. I'll wait for you guys to copy this down, and I'll wait for a question or 2. But I want to do the next problem, which says, when is the height 48 feet?
I got a question, Professor. So couldn't you have divided both sides by 16t and then still come up with t equals 6?
Oh, yeah. Yeah, because, but I didn't know how many people knew. You can't divide by 16t. You can divide by 16. You don't want to lose the t equals 0, because if you divide by t, it'll drop out of the problem, and it might be important. But you can divide by 16, sure. But I'm not sure how many people knew that. Okay. But yes, you could have done most of what you just said. All right. Can I do the third part? Can I erase this work here? T is 0, T is 16. 6, I mean. All right. All right. The third one is a little bit tricky. Okay. It says, the part B says, when is the height 48 feet? So question B, when is height equal to 48 feet? Again, the word when means our time is unknown. So somehow we're going to be solving for the time. We're going to be plugging in or doing something and solving for time. But this time our height is 48 feet. The last time our height was 0 because it said we were going to hit the ground where height was 0. So I'm just going to jump to the equation. We're going to write 48 equals negative 16t squared plus 96t. Okay, again, the height, looking back at this basic formula, the height is going to at some time be 48 feet. We don't know when. When we solve this problem, we'll be finding the times when it is 48 feet. Okay, so this was the height and the time is unknown. So we want to solve this. Again, I, Foster, like to make my squared term positive. So I'm going to do this. There's another way that this could have been done, maybe more efficient, but 16t squared minus 96t plus 48 equals 0. Okay, we solved that. It turns out that we can factor a 16 out, and I am going to do it this time. So that's going to give me t squared minus 6t plus 3 equals 0. Yeah. Okay, so here we go. Either, well, 16 equals 0, which is pretty dumb. Reject that. Or t squared minus 6t plus 3 equals 0. Okay. And this is so ludicrous, 16 equals 0, many instructors never even bother to write it. Okay, they just go, that's dumb, forget it. Okay, so now here's the problem. Okay, how do I solve that? Because you know what? It doesn't factor. Crap, it doesn't factor. So we have to use the quad formula. A is worth 1, B is -6, C is 3. So put it all in the quad formula. X is negative B, so negative of -6 plus or minus the square root of -6 squared minus 4 times 1 times 3. All divided by 2 times 1. So X is 6 plus or minus somebody divided by 2. This is going to be -6 squared is 36. Take away 12 is the square root of 24. Now hold on. Stop. Stop, 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 stop. Okay. We're going to have issues here. I need to erase the board or some of the board. So far, when we've been solving these, I've been asking you to always simplify your square roots. So back here, we have x equals 6 plus or minus the square root of 24 is 2 radical 6 over 2. Okay, it reduces. I can divide top and bottom by 2. So x is 3 plus or minus the square root of 6 over 1, which is just 3 plus or minus the square root of 6. Okay. And that kind of is a follow-up on the quad formula. We get 2 answers. However, what if I said, I want you to round your answer to the nearest 10th. This is called an exact answer. What if I said round your answer to the nearest 10th? That implies, if I say 10th, T-E-N-T-H, that implies decimals. So on your calculator, type in 3 plus square root of 6 and press enter. Okay, I'm going to do that. clear. 3 plus square root of 6, enter. And you got square root of 6 plus 3. You got a stupid answer. Okay. But then press the FD key. Now, other calculators will do this thing also. You just got to figure out which keys to press. But if you press the FD key this time, it will tell you your decimal. So it will say this is 5.44. If we round it to the nearest tenth, that was 5.4. Were you guys able to convert 3 plus radical 6? Okay, enter. It put on the screen 3 plus radical 6 again, which is dumb, but you press the FD key and it converts it to decimal. 5.44, who knows, 94, something, 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 whatever. But round to the nearest tenth. Okay. Can you convert 3 minus the square root of 6? Try that one. And I get 0.5505 something. If we round that to the nearest tenth, that's going to be 0.6. So, a couple things are happening here.
Hey, Professor, what mode does the calculator have to be on in order to get that answer? Because I'm having trouble.
You have the 36X Pro?
Yes.
Okay, mode. If you push the mode button, everything on the left-hand side, go arrow down, and do you see where it says math? The last line says classic or math print.
Yes.
Go over, make sure math print is highlighted.
All right.
So math print is how it does the square root of 24 and makes it look pretty. Okay. Then pressing the FD key should take it out of math print into decimal. Does that work for you?
No, it's not working.
Okay.
So is it 3 plus 6? Was it FD and then equals?
No, you 3 plus radical 6. Hit
Yep.
the enter key to enter it.
Okay, 3 plus 6. Enter. Okay.
And so it says radical 6 plus 3, right?
Yes.
He just repeats it. Now press the FD key. Just press it once.
Yes.
What happened?
All it did was just say answer FD.
What? Okay, let's go back to mode.
Mode.
Is everything on your screen on the left? So when you press mode, degree should be highlighted, norm, float, real, all of those on the left-hand side should be highlighted, are they?
Yes.
Okay, come down. Decimal is highlighted, DEC,
Yes.
but the last line, math print, is highlighted.
Yes.
Okay, so I'm going to quit that. Huh. Well, okay. Try it one more time. I'm 3 plus radical 6.
3 plus radical 6. Enter.
And it says radical 6 plus 3. And then, I know. Don't go second. Just press the silver key right below FD.
Okay. So 3 plus radical 6. And then
Now I know FD is above and you should press second, don't do that. Just press that silver key, the second one from the bottom.
Okay, now I got it.
Okay, so I was giving you kind of bad instructions. When I said FD key, we've always just pressed the silver button. You don't have to go second FD, just FD, just that silver button. Okay, so this is my bad. All right, now I need to explain what this is. This problem has two answers, depending on the directions, guys. If I said, give me the exact answer, these would be the exact answer. But if I told you to round it to a decimal, then you have to go through this process to round to a certain decimal. Now, this particular problem on the worksheet didn't tell you that. Okay, I just kind of made that up. It didn't say anything about rounding. It didn't say anything about exact answer versus rounded answer. But you're going to find questions on MOM. You're going to find questions. I'm going to make a worksheet available to you for practice on this. That'll say round your answer to 4 decimal places or round your answer to the nearest 10th. So you have to pay attention to whatever the directions say. Okay, wait, is it possible to have the height be 48 twice? Can the height possibly be 48 twice if you shoot something up in the air and it comes back down? Let's think about that, okay? So I shoot something in the air, it comes back down. We've already figured out that it hits the ground after 6 seconds. That's okay. Okay. What this is saying is somewhere the height is 48 feet. Okay, somewhere. So what we've just figured out is at 0.6 seconds, okay, the height was 48 feet and the object was still going up. And then we also figured out over here at 5.4 seconds, okay, the height was also 48 feet, but now the object was on the way down. So this particular problem, the two answers are viable answers. They're very good answers. The object is going up, hits 48 feet on the way up, okay, hits its max point, and then comes down. Now, later, we're going to learn how to find that max point, but not right now. All right, I want to move on to some of problem number 2, not all of it. I want you guys to try that. I think you'll notice that the answers are on the back page to all of these. So you should be able to try these over the weekend. Okay, number 2 is more normal, is more like I'm going to show you on a test or exam. Okay, so problem number 2 says, on a distant planet in a galaxy far, far away, a princess with funny hair buns stands on a hill that's 120 meters above the sea, throws a stone in the air with a velocity of 40 meters per second. Okay, blah, 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 blah. Number 2, I gave you part of the formula. I said h of t is negative 10 t squared plus v naught t, remember v sub 0 is v naught t, plus h naught. Okay, in the problem, it says that. I promised you I would give you this number always. That's the force of gravity. That's the effect of gravity on different planets with different units, you know, feet per second, meters per second, that kind of stuff. So that one I gave you. You never have to worry about that. But according to this problem, what is V naught? V sub 0. So on a distant galaxy far, far away, princess stands on the hill. What's the 120? She stands on a hill that's 120. That's her initial height. The 120 is the initial height of when the princess is going to throw this rock. Okay, so this problem, okay, she's standing on a hill that's 120 meters high, and then she's going to throw the rock and it's going to come back down and hit the ground. So she's starting up 120. Okay, 40 meters per second is speed, velocity. So what you're supposed to do when you read this problem is say, oh, this is the equation or the function I want to use. Okay, this is the function I want to use. H, I gave you the force of gravity, the negative 10 t squared. That was just given. Cool. You had to read the problem and figure out that 40 meters per second is the speed, like miles per hour, meters per second. Okay, 40 meters per second is the speed or the velocity, and the initial height, h sub 0, or I call it h naught, is 120. She starts on the top of a hill. That's 120 meters above sea level, throws a rock up, it comes down. Okay, so I'm not going to do problem 2 for you now. It asks the same questions as problem number 1 does, but it has a slightly different formula. So you're going to do exactly the same thing in problem number 2 that you did in problem number 1, but you have now a different formula because we have different parameters. We're on a different planet. We have a different initial velocity, and we have a different initial height. Again, the answers are in the back. I want to jump down to number 5 now. Okay, number 5, a rectangle has an area of 54 meters squared. One side is 6 less than its adjacent side. Find the length of the shortest side. All right, so number 5, first thing, if I can draw a picture, I do draw a picture, always. So it says I got a rectangle. I know that the area of this rectangle is 54. Okay, one side is 6 less than its adjacent. The word adjacent, A-D-J-A-C-E-N-T, means next to. Adjacent, next to. The house adjacent to me is the house next to me. Okay, the car adjacent to me in the line is the car next to me. So I have a rectangle, okay? One side is 6 less than the other side. That tells me that this is 6, this is x, and this is x minus 6. Doesn't matter. One of them's x. Somebody always is x. But it says the next side, the side adjacent to it, is 6 less than. Less than means subtract. Now, the question is how do I put all this crud together? Well, that's where those formulas come in. You need to know that area is length times width. You need to know that basic formula. The area of a rectangle is length times width. Okay, talked about that first or second, well, first week sometime. So we plug in everything. We get 54. The area is 54 equals the length, I guess it's x, times the width, x minus 6. So the formula guides us. It tells us where to plug those numbers in. The area was 54. It equals the length was x. The width was x minus 6. And it doesn't matter if you got length and width mixed up. They'll work out. So now you answer this, or you solve this rather. 54 equals x squared minus 6x. Okay. You go, okay, power of 2. I want to make it equal 0. I want to make it equal 0 because that was my rule for factoring or the quad formula, whichever one I might want to use. Okay, I might want to use, I either factor or quad formula, but it's got to equal 0. Now, I really wish I could factor this. My AC is negative 54. Oops, negative 54. Okay, so what times what makes 54? Okay, did I copy it right? Please make sure I copied it right. 54, yeah. Okay. But if I break it down, that's 9 times 6. That doesn't work. Can I do anything else? Or do I just go to the quad formula? See, that's what you guys have to decide. That's 3 times 3 times 3 times 2. Nah, there's no way I can put that together. So I would say factoring fails. Okay, factoring fails on this one. So I have to go to the quad formula. And that's what you guys have to decide. You get the problem set up, drew your picture. Somebody is X, somebody else was 6 less than X, smaller than X. Okay, you pop them into the formula, you start to solve, and then you go, oh, crud. How do I solve that? Factor is easier, faster. Quad formula works all the time. That's your rule of thumb. Factoring, easier, faster. But quad formula always works. Well, factoring didn't work. So I'm not even going to try. I'm just going to go to the quad formula. So A is worth 1, B is worth negative 6, C is worth negative 54. So quad formula, X is, again, guys, you have to have the quad formula memorized. Have to. X is negative of negative 6, negative B, plus or minus the square root of negative 6 squared, B squared, minus 4 times A, which is 1, times C, which is negative 54, all divided by 2 times 1. Okay. So this is just ugly. X is 6 plus or minus somebody divided by 2, all divided by 2. So let me see if I can do it right. I get 252 inside of there. Because that's 36 minus a negative 216. So it'd be 36 minus a negative 216. Okay. But remember, minus and minus means add them together. So that's why I got 252. Okay. Now what's the square root of 252? Okay, 6 root 7. So X is 6 plus or minus 6 radical 7 over 2. We can divide top and bottom by 2. That gives me x equals 3 plus or minus 3 radical 7 over 1. I don't need the 1 anymore. Okay, now hang on. We're going to have an issue here. Okay, these are my exact answers. And again, my directions weren't very good on this handout. My directions weren't very good because I don't know if I want to go to decimal or not. So what I want you guys to do is take a few minutes, and x could be 3, not a few minutes, a few seconds, plus 3 radical 7, turn that into a decimal, and x equals 3 minus 3 radical 7. Turn that into a decimal. Wow. Yeah. IVC, I see you. I just turned you into a co-host.
Hi.
In a second, I'm going to split us. I'm going to explain kind of what the evening's about. I'm almost done.
Yeah, no rush.
Okay. Okay, so what did I get for this? Let me see what I got. 3 plus 3 radical 7. Okay, FD. So I got, for 3 plus 3 radical 7, I got 10.937 something or other. And I don't know, I haven't told you what to round to, so we're faking it right now. Okay, but this is the rounded or the approximate answer. PPROX, good. Okay, down here, repeat it again, clear. 3 minus 3 radical 7. Okay, FD it. And I get negative 4.937. Okay. So did you guys get that answer? Can you guys, first off, do you accept my algebra here in getting 3 plus or minus 3 root 7? That, and then using my FD key or my approximation keys, did you get those two? Can anybody confirm?
Yes.
Yes, okay. I heard one person say yes, so I'm happy. Yay. Okay. Problem is it's wrong. If you put both of those answers down, you would get the answer wrong. Even if you put this one down, you're still going to get the answer wrong. Why? Can anybody tell me?
We're looking for the shortest side.
Okay. And what else? That you're right.
In meters.
Man, more than that.
Can't be negative.
Wouldn't be
Can't
because one
be
of the answers is
negative.
negative.
That's the point. Two of you guys said it. Good. And we have to find the shortest side. So hang on. There's a lot of little things in here you guys got to be thinking about. Okay. First off, by converting it to decimal, we can see that, according to my algebra, one of these x's is negative, a negative number. But wait, can x be negative? No, not even close. You can't have a negative length of something. So this answer right here should be rejected. Okay? Just because x can't be negative. So you just throw it out and go, it can't be. In our previous problem, we could have the parabola go up and down, hit 48 twice. The previous problem, we could get 2 answers. This problem, we can't get 2 answers. Okay? Now, the other thing is it wants the shorter leg. Well, we found x. What's 10 point, whatever it is, 9. Okay? But wouldn't this be shorter? Wouldn't taking 6 away from it make it the shorter leg? So if we said x equaled 10.9, just to round it, then this should be 4.9 because you subtracted 6. 10 take away 6 is 4. 4.9. So there's a lot of things you guys are going to need to read and think about in these problems. Read and think about. It's not going to be enough just to set up the problem and solve it. Okay? Solve it this way. Now you're going to be asked to sometimes give an exact answer and sometimes give a decimal answer. And now you're going to have to worry about whether somebody rejects or not. Holy crap. Life just got tough. But fortunately, we have a couple of weeks before we get to the test on this stuff. So you guys got a lot of time. I do not have time tonight to do the Pythagorean formula. We've done a couple of those. You can get started. We'll do those next week when we reconvene after the exam. All I can tell you is that when you set up your formula for the Pythagoras, oops, you got leg, and you got hypotenuse. Okay. And when you set this up as leg squared plus leg squared equals hypotenuse squared, you're probably going to have to use the quadratic formula to solve that equation. That's the difference between now versus chapter 7. We did these in chapter 7, but in chapter 7, everybody factored. It was nice and pretty. We're doing exactly the same thing now in chapter 9, except when you get down to solving, you'll have to use the quad formula, probably. Okay? All right. That's it. I promised 7:30. I'm 3 minutes over. Shoot me. No, don't, please. That used to be funny. Now, these days, who knows what the hell is going to happen. Okay, what Lisi and I came up with, the plan, was that we would like to divide the class into 2 groups. Okay, Lisi will take one group in a breakout room. I'll take another group staying here on the main page.
By choice, yeah.
By choice, yes. You will get to choose whichever room you want. However, okay, Lisi has almost exact problems. Now, you can ask questions of either of us, but Lisi has problems that are almost exactly like what's going to be on the test, so that might help you a little bit. She's not going to tell you exactly what they're, or she's not going to hold it up and say this problem and this problem, okay? But any examples she gives you will probably be quite a bit like the exam. I, on the other hand, am going to sit here and answer questions. But if you don't ask questions, I ain't going to do anything. Okay? You're welcome to, I think I've got my Zoom set up so you can exit my room and go into hers, or exit her room and go into me. I think I've got it set up that way. The worst that happens is if you can't get out, you can log off and then log back in, and you'll come back into the main room here. So does that, Lisa, is that kind of what we discussed? Is that what you heard?
Yeah, absolutely. I'll just be in another breakout room, and feel free to come work on examples with me. I'm not going to probably, it's more for review. I definitely will want people to help me work through the problems. But yeah, whoever wants to practice, and I'm there.
Remember though, her practice problems are, I've given her several major hints about what's going to be on the test.
It's true. I have hints, and we're definitely just going to be going over stuff that you will certainly need to know.
Yeah.
So if you practice, never hurts.
So if you go with her, you get a specific help. If you go with me, I'll try and answer your questions. I will still give you help, but you have to ask me the questions. Now, I've got to figure out, I haven't used breakout rooms in forever. So let participants decide. I want one breakout room. Boom, here I go. So you guys get to decide whether you want to go into room 1 or stay with me or go home. So select who you wish to join.
So Professor, I guess I won't see you again. So I'll see you next week.
All right. Thank you.
Okay.
Mm-hmm. Wow. Nobody loves me. Everybody hates me. Guess I'll go eat worms. Anybody remember that song? Okay. Those of you that are here, does anybody have any questions? Either, you can ask questions on anything and I'll try and answer them, but I'm waiting for you to ask me the questions.
I was wondering if there was another form to simplify square roots, because sometimes I'm having trouble to simplify them.
Okay. Square roots, okay, first off, what kind of calculator do you have?
I have a Casio.
Oh, okay. So yours doesn't do all the fancy stuff. No problem.
Or can you refresh on how to make them, please? Because I have another form, but I'm having trouble.
Well, okay. What I think I hear you saying is you want to know how to simplify like the square root of 27x to the third, y to the fourth, something like that?
Yes.
Okay. So what we do is we go off to the side and we take 27. You do this on your scratch paper, and you use your times tables. So that's 9 times 3. And you break it down into 3 times 3 times 3. Okay. And then you put it back together as 3 to the second power times 3. So this is your scratch work, but you redo it as 3 to the second power times an extra 3. Okay, hang on, let me close this. Okay. Why? Because this is a square root. Does the 2 show up there?
Yes.
Can you see the 2? Okay.
Yes, I can.
Okay. So if that's a square root, you want to break everything into square powers. Well, if we take x to the third, that is x to the second times an extra x. We want to take everything here and break it into powers of 2.
Okay.
Because it's square root. So y to the fourth is going to be y to the second, y to the second.
Okay.
Okay, now, hang on, we're not quite done.
Okay.
Now, what comes out?
The 3 to,
The 3?
And the other 3 stays, right?
Yep.
Okay. And the x to the second too. And the, well, I guess the 2 y's, no?
Exactly. Yeah.
Okay.
So those all come out, but this is the trick that bugs people. When they come out, they lose their power. So the 3 squared comes out as a 3. The x squared comes out as an x. The first y comes out as a y. The second y comes out as a y. And who's left inside?
3 and
3x.
x. Okay. And,
Okay. Okay. And then we put these two together to make them look pretty. So we say 3x y to the second times the square root of 3x. And that would be our final answer. I know you've asked a question. I've cut you off a couple times, but is that okay?
No. Don't worry. You answer all of my questions.
Okay. Is that okay though?
Yes, it's okay.
All right.
I know I have lots of other questions, but can I check on mom to see which ones? Because I have questions about homework.
Okay. Yeah, I will be here. Let me do one more problem for you here
of course.
before you go. Okay. What if we did the cube root of 27 x to the third y to the fourth? Instead of a square root, what if we did a cube root?
Well, I guess it'd be the same, only like the 1's power to the third power will come out, no?
Right. So 27, I've done the work up here. It is 3 to the third. Before I used it as 3 to the second times 3 because it was a square root. Now I'm just using it as 3 to the third.
Okay.
X to the third, because it was already there. But what about y to the fourth? What do I got to do with it?
I guess you can write it as y to the third times y.
Yep.
Okay.
So who comes out?
The 3, the x, and 1y, and the other y stays in.
So you're right. 3xy, they came out and they got stripped of their power. The power gets lost on the way out.
Yeah.
And we have then the cube root of the y that stayed inside, and that would be the answer there.
Okay.
All right. So I will stay here until everybody either leaves my room or Lisi's room. Okay. And if you want to keep asking questions all night long, we can, well, not quite all night long, but we can answer, you can answer. So if you want to go back to look at mom and then come back and ask questions, that's fine.
Yeah, I will stay here, but I will go to mom and write down my questions because sometimes I'm having trouble solving some problems.
Okay. Go for it. Go for it.
Thank you.